In this video, we will see the different types of functions. To start with, let's do the one-to-one function. Now, in a one-to-one function, let me explain that there is a domain. The domain maps to range through the relationship of function f. Okay, so the function f maps x to y from x to y, which means every element in x will be related to y through the function f. So in such a function, which is one-to-one, every individual element in x will have a distinct element that is related to in y. All right, so you can call that as, one will form an image of b, and this b will not be an image of any other elements in x. So each element will have a distinct relationship with every element in y. All right, so that's a one-to-one relationship. In other words, 2 is related to a. Okay, now 1 cannot be related to a because a has to be distinct. A should have only one relation or one domain in this function. All right, so that's the one-to-one function. Next, many-to-one function. Just as the name states, you can have many, like you can see in this picture. 1 and 2 are related through function f to x. So many of the elements in the domain can have one element that is related to in the range. All right. Next, before I go into the next one, onto relationships, these functions are all a little bit confusing for people. So I want to illustrate with an example. Look at this parrot, and it's sitting on a mango tree. Now, we all know the parrots love to eat fruits. And if you ever visited a parrot cage, all that you will find is fruits. So definitely this parrot is sitting here for the mango. It's looking out for the ripe mango that it can eat. So if you call all the mangoes in this tree as a set, okay, and if this is our codomain, which is the superset of range, if these terms are not familiar to you, just imagine this is a set of mangoes which are both ripe and non-ripe, and let's call the parrot as our relationship from, which is x is the parrot. So we're going to establish a relationship from the parrot to the mango. Okay, so parrot will be called the domain, and the mango will be called the codomain, and the range also is the mangoes. Right. This is called an into function. Now, consider this set y. In this set y, let's say that this set y contains all the mangoes that are there in this tree. Y has all the mangoes in the tree. And this blue indicates the ripe mangoes, which are very delicious. And the white indicates the mangoes that are not ripe. You can probably make a pickle out of it. But this is the blue indicates the ripe mangoes. Now the parrot can be in the domain 1, 2, 3. Let's call them like there is a parrot number 1, parrot number 2, parrot number 3. Now all these parrots will go for the ripe mango or the unripe mango. Yes, it will all go for the ripe mangoes. All right. So, but this set has ripe and unripe mangoes. So the codomain means it's the full set. Here in this case, all the mangoes in the tree, all right? And that's codomain. And our range is the function, the relationship the parrot will go for the ripe mangoes. So that's the function, that's the relationship. So the ripe mangoes is called the range. Okay, I think it's clear now for you. So that's a range, that's the codomain. Codomain is all the fruits in the tree, and range is a subset of codomain with all the ripe mangoes. So in a into function, there will be elements in Y or in codomain where the mapping is not taking place from X to all the elements. It is mapped only to certain elements in the codomain, and that is called the range. In other words, the range is smaller than codomain. Range and codomain are not equal. All right? So that's a into function. Now, similarly, the onto function is just the opposite. Your range and your codomain will be equal. So, I cannot illustrate this for this. You should have a different example, but it's more easy for you to visualize now. In a onto function, 1, 2, 3, which is X, will map to the range AB here, okay, in the set Y. And there is no other elements left out in this codomain except what is in the range. The range and the codomain are equal. All right. So that's an onto function, and this is an into function. So next, let's go on to what is a bijection. Bijection is a combination of both an onto function and a one-to-one function. When both these properties exist in a function, then that function is called a bijection. Then a function is called a constant function if all the elements in the domain has the function related to only one element in the range. Whatever you do, you get B from X. They never go to A and C. Let's just consider that you have you're a top scorer. You always score 100 in mathematics. So and we all mathematicians love to see the 100. And so let's say whatever be the test, the first term test, second term test, third term test, all points to 100, nothing else. Your range, even though you can have so many marks from 1 to 100, but they are always coming to 100. It's just an example, and just an illustration. So in a constant function, every element in the domain X will be related through the function f to only one element. Great. Next. In an identity function, the function f will map from X to Y in such a way that every element in X, let's say A is an element in X, when you do the function mapping, will give an image of A, which means it will produce the same value of its original domain. So that's an identity function. And functions is a very important topic. As you go into higher studies in mathematics, these functions are very, very useful. You'll find them, especially when you're doing integral calculus. So have a good foundation, and I'm sure that you will succeed in life. Thank you for watching Maths Tutorial Anand. Please like, and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.